All right, this is a 11.4. We're talking about three-dimensional figures. So we are moving off two-dimensional, which means flat, and kind of moving into 3 dimensions. And specifically, we're going to be talking about polyhedrons, which is a solid. And essentially, a solid is just a three-dimensional shape. So it's a solid bounded by polygons called faces, which have no curved edges. So if we remember that a polygon is any shape that has all like hard flat sides. It could be concave, convex. But essentially, if all of the faces are enclosed like that, that makes it a polyhedron. There are also edges and vertices. So the edges would be line segments formed where two faces intersect. So here, that right there would be an edge. And the vertices are a point where 3 or more edges meet. So in this case, this is an example of a vertex. And kind of in the gray is a face. So all of those pieces kind of come together to form a polyhedron. And there's something called Euler's formula, which is just for any polyhedron this works. And it's, so your number of faces is F. Your number of vertices is V. And your number of edges is E. Pretty easy to remember. But so for any polyhedron, the number of faces plus the number of vertices equals the edges plus 2. So here we have a rectangular prism. So the number of faces, you have the top and bottom is 2, left and right side is 4, and the front and back is 6. The edges, we have 1, 2, 3, 4 on the top, 5, 6, 7, 8 on the bottom, 9, 10, 11, 12, kind of connecting them up and down. And then the vertices, 1, 2, 3, 4 on top, 5, 6, 7, 8 on the bottom. So vertices plus faces plus vertices equals edges plus 2. We have 6 plus 8 equals 12 plus 2, 14 equals 14. So if you know the number of faces, if you know 2 of these things, whether it's faces and edges or vertices and edges or faces and vertices, you can find that third one. So there are 2 types of solids. There are polyhedra that we just talked about, and then there are non-polyhedra. So they have curved edges or slopes or no edges at all in the case of a sphere. So these are this is a prism. This is a pyramid. This is a cylinder, a cone, and a sphere. These are the most basic ones we're going to talk about. A prism and a pyramid are specific, and they're named by their base. So in this case, the base is a rectangle, so this is a rectangular prism. Here the base is a rectangle, so it's a rectangular pyramid. If you had one that was a hexagon, something like this, this would be a hexagonal prism because that base is a hexagon. So we're working in three-dimensional space, and that kind of leads itself into our next thing, which is cross-sections. And cross-sections are essentially if I took a plane or a piece of paper and sliced through a solid, what does it create? So a cross-section is the intersection between a plane and a solid. The intersection between a plane and a solid that creates a two-dimensional shape. And where you cut it kind of determines the kind of shape you create. So here, I have a cube. All three of these are cubes, but depending on where you cut it, you get a different shape. So if you go kind of parallel with the base or the top, it's actually going to give you an exact square. If you do it at an angle or diagonally, your cross section is going to be a rectangle. And then if you do it on an angle and don't go and only pass through kind of the corner, you're going to get a triangle. So all of that affects the way this works. So we're going to actually jump into part 2 now.